Hey guys, we're going to do 10.6, and I'm going to do it as one complete video because I think it might actually help. So let me go to the beginning of this. Okay. So we're talking about categorical data in this video, and I really like that you get to see categorical data because we don't get to use it, or in other words, qualitative data. We don't get to really use it a lot in this class, so let's go ahead and look at it. To perform a chi-square test for goodness of fit. All right. So there's two different alternatives, null and a hypothesis for this chi-square test of goodness of fit. So the first one is that you're saying all the probabilities for the various outcomes are all the same. So you'd write it as probability 1 equals probability 2 equals all the way through the probability or last category for the null. Your alternative is there's at least some differences among the probabilities. So if the probabilities aren't the same, then you kind of write it as the null would be the probability of category 1 is this, the probability of category 2 is this, all the way to the last category. And again, your alternative would be there's some kind of differences for the stated probability. So the test statistic for the chi-square test of goodness of fit is chi-squared equals sigma, which is the summation of all the observed minus the expected squared over the expected. Degrees of freedom, we're going to use that for the chi-square test statistic, but the degrees of freedom is the number of categories minus 1, or the groups that you're looking at minus 1. Rejecting the null. If we're going to do it based on the chi-squared, it's your chi-squared is greater than or equal to your chi-squared alpha. Okay, let's do an example not using the calculator, and then we're going to use an example using the calculator. A local bank wants to evaluate the uses of its ATMs. Currently, the bank manager assumes that the ATM is used consistently throughout the week, including the weekends. She decides to use a statistical inference with a 0.05 level of significance to test a customer's claim that the ATM is much busier on some days of the week than the others. During a randomly selected week, the bank records the number of times the ATM was used on each day. The results are listed in the following table. Okay, so what we're seeing is this is all our observed data. This is what was actually seen, and this is what was recorded. So Monday there were 38, Tuesday 33, Wednesday 41, Thursday 25, Friday 22, Saturday 38, and Sunday 45. Okay, so let's state our null and alternative hypothesis. So the null is the proportion of customers who use the ATM do not vary by the day of the week. The alternative is the proportions of customers who use the ATM do not vary by the day of the week. Do vary by the day of the week. So what we're seeing let me put it in English for the null. The null means that the number of people that came to the ATM on Monday is the same as Tuesday, is the same as Wednesday, is the same as Thursday, is the same as Friday, is the same as Saturday, is the same as Sunday. The alternative is saying, okay, at least one of those days there was a difference in people. You can write it mathematically as this. This is the easiest way to write it, okay? All right, so we know our level of significance is 0.5. So let's go ahead and start looking at what we got to do. Okay, so we've got our observed, and that was what was in the table. Now we've got to do our expected. So all our expected is we add up all the observed together and divide it by the number of categories. Well, in this case, our categories is days of the week, which is 7. So 242 divided by 7. And then we do this nasty thing by hand or on the calculator. So let's break it down what we're actually looking at. So the first one is 38 minus 242 over 7, parentheses, squared over 242 divided by 7. That's Mondays. And then we're going to do it for Tuesdays, where you see the 33 minus 242 divided by 7 squared over 242 divided by 7. That's Tuesdays. And there's one for each day of the week. This is getting the chi-squared test statistic. So if you look at the bottom, it's 12.314. I promise there's an easier way to do it in the calculator. So we're going to draw a conclusion and interpret the results. So the number of degrees of freedom for this chi-squared distribution is 7 minus 1 equals 6. and the alpha is 0.05. So using the table in the back of your book, it's called the critical value of chi-squared. So you're going to go look up the value. So if you go in the book and you look up the 0.050, and then you go down to number 6, you're going to see 12.592. This table is also found in the back cover of your book. So we can use this for rejection rules. So we know that 12.592 is what divides the fail to reject to the reject the null. So 12.314, if you see, falls in the region of fails to reject. So we fail to reject the null, which means there's no evidence to support the customer's claim that the ATM is used significantly more than any particular day of the week. All right, so let's look at it if the proportions are different. Okay, so there's a fast food restaurant and they serve buffalo wings. The restaurant manager notices that they normally say the following proportion of flavors for their wings: 20% spicy garlic, 50% classic medium, 10% teriyaki, 10% honey barbecue, and 10% Asian zing. So he's going to run a campaign, and he gets his results after 10 days. He puts them in the following table. Okay, so this is his observed. Spicy garlic's 251, classic medium 630, teriyaki is 115, hot barbecue is 141, Asian zing is 121. So is there sufficient evidence at the 0.05 level of significance to say this made any difference? So we're going to state our null and alternative hypothesis. Because they actually gave us the proportions, they're all different, just state them as the null is P1 equals the proportion of 0.20, P2 is 0.50, P3 is 0.10, and so on. So you don't even have to use the names. You can just use probability 1 equals this. So then your alternative is there's just some difference for the stated probabilities. Because one could be different, they could all be different, you never know. We're just seeing that there's a difference. Alright, so we're going to determine what to use. So we know this is a chi-squared statistics or test because it's categories. So let's go get the expected value. So we're going to add all our observed together, which is 1,258. But it's going to be different for each one except for the last 3, because the proportion of our first one is 0.20 and the proportion of our second one is 0.50. So this is how they're getting our expected values. So now instead of using that huge table, let's do this. Get out your calculator. Go hit Stat. And then go to Edit. Okay. In L1, you're going to put all your observed values. There was 251, 630, 115, 141, and 121. In L2, you're going to put all your, expected values. L1's going to be observed, L1's your observed. That's what we saw in the table. That's what the guy, when he got all the wing orders and tallied them up, that's his observed. L2 is your expected. We just did that in the last slide. So it's going to be 251.6, 629, 125.8, 125.8, and 125.8. Okay, from here go Stat, go over to Test, scroll to Test, okay? Go all the way down past number 0. Then you go see A, B, C, D. Go to D, hit Enter. Okay. Observed is going to be L1, which is correct. Expected is going to be L2. DF, you need to change that because your default might say 5. You need to change that to 4 because 5 minus 1 equals 4. Go ahead, select Calculate, and then hit Enter. So then what you get is you get a chi-squared of 2.949, a p-value of 0.5662, a DF of 4. Okay, let's reject this based on the p-value this time. So we know if a p-value is less than or equal to alpha, then we can reject the null. In this case, the p-value, which is 0.566, is greater than the alpha of 0.05, so we fail to reject the null hypothesis. Which means the proportion of wing flavors sold doesn't support the claim. The restaurant can't say that the promotional campaign has made any difference in that evidence. So that's how you use the calculator. I would practice with this in Hawks and let me know if you have any questions. Thanks.